Okay, so if we want to relate it to functions, if we have an arithmetic sequence which we have a common difference, say for example, 7 and so on. We say that this one is arithmetic because what's the common difference? The common difference is 2. And set it as a function. We have our first, second, and we have those values 1, 3, 5, 7. What do you think will be the picture of the graph? If you plot 1, 1, 2, look like? It'll be a line, right? So we have this sketch here. So 1, 1, 2 will be 3, 3 will be 5. Okay, let's plot it. 1, 1, 2, 3, 3, 5, and 4, 7. So far, are we understanding it? The connection between these numbers into a corresponding graph. And in general, how do we describe the equation of a linear function? If we say that's a line, do you still remember the format? What's the format of the equation of a line? Y equals mx plus b. Do you remember this? So in our case, we can relate this one as well to our slope function. But instead of me writing it like that, I want us to write it as b plus mx. Which tells us that in this function, our initial value is b, but in this equation, our initial value is a sub 1. And then here, our constant rate of change will be m, but on the other side, it's going to be d. Okay, and then on the linear function side, we also have this format, plus m, x minus x sub 1. If you're given 2 points, and then we have this for the arithmetic sequence. And then could you please jump to page 3 where it's labeled practice. Let's try on examples to identify them. Okay, let's look at number 2. Okay, I'm skipping number 1 because that's neither. You will figure out later on. But first, if you look at this one, 10, 11, and 12, that's your numbering for the term. But if you look at 30, 20, and 10, what's the pattern, guys?
Minus 10.
Minus 10, and then here it's also minus 10. So based on that, is it common? So we say yes, it's common. So what's our answer to this one? It's linear. Okay, how about the third one? Between 20, so we know that 13, 14, 15 are uniform. So we just need to know if the y values would also be having a common difference. So between 20 and 4, what's the difference?
5 division. No. Minus 16.
Minus 16.
20 to 4?
But between 4 to 4 over 5, we can say that it doesn't make sense, right? But let's say this one is, sorry, my bad. This one is a no for a common difference. But let's try to see if it's something about multiplication. If we multiply between 2 and 4, what should I multiply to 20 to get 4?
5.
Times 5? Or do we multiply it by times 1 over 5?
Oh, my bad.
Okay, correct? And how do we get to 4 over 5?
1 over 5.
We also multiply it by 1 over 5. So yes, this one has a common ratio instead. Now what can we say if it's a common ratio instead of a common difference? We say this is an exponential function. Okay, could you please do the same thing on number 1 and number 4? Just pick one number. Then I want you to see if it has a common difference or a common ratio. Okay, for number 1, do they have a common difference?
No.
No, they don't. Do they have a common number to multiply?
No.
Also no. Right? First, if you look at the difference, I'll use a pen this time. Between 2 and 8, what's the common difference?
6.
It's a plus 6. How about 8 to 20?
12.
It's a plus 12. So we say, no, there's no common difference. Now let's see if there's something we can multiply. Between 2 and 8, we need to multiply 4. And between 8 to 20, we need to multiply
2.5.
or 5 over 2. Which means it's also no. So what's our conclusion? This is neither linear nor exponential. So far, are we getting it? Okay. For number 4, who tried this one? Is it linear or exponential? Will, what's your answer?
I don't think it's either.
Okay, that's correct. Between 6 and 12, the difference is
6.
plus 6. To 12 to 20 is
8.
plus 8. So what's our conclusion? No, they don't have a common difference. But do they have a common ratio? 6 to 12 means times 2. 12 to 20 means times 5 over 3. So what's our conclusion? It's still a no. So neither exponential nor linear. Okay, number 5, 6, 7, and 8 are very much easier to see because you only need to focus on the y values here. But first, if you look at 1, 5, and 9, what's the distance, guys? 4 and 4. So we can check the second value. How about this one? Do they have same pattern? Yes, it's negative. It's plus 2 and plus 2. How about this one? 3 and 3. How about 11 to 20? 5 and then 20 to 29? So the only number that we cannot answer is number 8. Are we good with that? So we say 8 is automatically, where's my condition here? Oh wait, this is both 9, right? 11 to 9, both 9, okay. Okay, explore again. 5, 6, 7, 8. Tell which ones are linear or which ones are exponential. So at least you know now coverage for the summative next meeting will be about this one, finding which ones are linear and exponential, as well as the arithmetic and geometric sequence, finding a missing term. What's the number? What's the common ratio? Because we said it's not common, just the ratio. So what is that common ratio? So it's 2. Yeah. So do another layer and then say. What?
So exponential is when you add fractions. Is it exponential used division and multiplication?
It's not the common difference. This we don't have the difference.
Oh, so this one being exponential. So that might be a match, and these two might be
Okay, not many of you are absent usually on the 4th period, but still I'm recording it for the 1st period. Are we okay? Right? Okay, so for number 5, what's your conclusion? Is it linear or exponential? Correct, this one is exponential. Will, why do we say so that it's exponential? Okay, so instead of adding, we multiply a number. What's the number? Times 3 and times 3. That's good. Next, Gibson. For number 6, exponential or linear? What's the common difference? And -4. Guys, are you now able to distinguish a common difference from a common ratio? We good? Alright. So this one is linear. Next, Henry. Number 7. So if you say linear, what's the common difference?
plus 100.
Plus 100 plus 100. So this is linear. Correct. And lastly, Lexa, number 8. I see you're still working. That's okay. Nestor, number 8. Exponential. So what's the common ratio? Times 1/2. Do you agree, people? Okay. So this one is exponential. Okay, guys, we're almost there. One last format to do. What if it's not written in a set notation nor a table? Instead, you're given the format. Let's say for number 9. Is number 9 linear or exponential? This is exponential. Guys, look at the format. What is our basis to say that it's exponential? What is the common ratio? Nope. What's the common ratio? 7. Guys, look at the format again, okay? Next, number 10. Linear or exponential? Guys, linear or exponential? Oops, I see that you don't see it. Number 10. This one is linear. What's the common difference, everyone? That's the y-intercept, right? -6 is the y-intercept. So what is the common difference? 4. If you go back to the first page, we say D or M. That's going to be your common difference. I want to try cake this time. Number 11, what's the decision? Linear or exponential? Linear. What's the common difference? Wrong answer. Ariel, linear or exponential? Number 11. Linear. So what is the common difference?
2.
That's the y-intercept. I want to try Hannah. Linear or exponential? What's the common difference? Wrong answer. Devin, linear or exponential? Linear. What's the common difference?
-9.
-9. If you say 9, that's automatically wrong. This question appeared in the AP classroom also. I tried it and they marked my answer wrong. So I'm learning from my mistake too. Number 12. Guys, I think it's obvious to see which ones are linear and exponential, right?
Yes.
When do you say it's exponential?
There's multiplication.
And there's an exponent, right? If it's linear, it's flat. Okay. Number 12, may I ask for Cassandra? Linear or exponential? Exponential. Therefore, what is the common ratio? Correct. Common ratio is 2/5. Next, Jordan, number 13. This one is tricky. It's not in its complete form. But linear or exponential? Linear. What's the common difference? No, it's not. Actually, it's correct. -5. I was just testing it. So what's the complete form of this? This will become -5x plus, sorry, this is -5 times 20 times -27, so that's gonna be, my bad, -5x minus 13. Am I right? Ezekiel, number 14. Linear or exponential? Okay, I'll be back. Phil, number 14. Linear or exponential? Exponential. What's the common ratio then? 3/4. Correct. Hannah, 15. Linear or exponential?
Exponential.
What's the common ratio?
1/6.
Nope, it's not. It's 2. And lastly, number 16. They ask for Lexa. Linear, exponential? Linear. What's the common difference? 3. Correct.